So this problem is from page 359 of the textbook Pre-Calculus with Limits, a graphing approach. It's problem 112. It states that the rate of change of a function f of x is equal to the secant of x plus the cosine of x is given by the expression the secant of x times the tangent of x minus sine of x. So that would be that the derivative of f of x, or I'm going to write that out here, f prime of x, is going to be equal to secant of x times the tangent of x minus the sine of x. So that's basically given that f of x is equal to secant x plus cosine x. Yeah, sure, that's an x. Go with it. But that's not really what's important, the rate of change thing. They also tell us that this expression, so the first expression, secant x tan x minus sine of x, the rate of change, can also be written as sine x tangent squared of x, hence they're equal. So the biggest statement of this problem is that, I'm going to go with, what color should I go with here? I think I'll go with, let's go with green. The secant of x times the tangent of x minus the sine of x is equal to the, what is it, secant of x times, no, that's not what they give us, sine of x times tangent squared of x. Sine of x, not sine of n, sine of x times the tangent squared of x. So this is their main statement in the problem. And we're meant to verify that this is indeed correct, given the information here, using various trigonometric identities that we've learned. So when I do these problems, I like to start by changing everything into sines and cosines. It just helps simplify things out for me. So we know that the secant of x is 1 over cosine. So we have 1 over cosine of x times tangent of x is sine over cosine. So sine of x over cosine of x minus the sine of x is equal to the sine of x times the tangent squared of x. So that's going to be times sine squared of x over, that's a squared, over cosine squared of x. So how can we simplify this a little bit? Well, on the left side, well, how about we divide both sides by sine? I think that would simplify things. So this is going to be, well, these are multiplied here. So we're just going to pull a sine out of that. So we're going to have 1 over cosine squared of x minus 1, right? That's dividing sine out. We have to divide the other side by sine too. So that's going to be times sine squared of x over cosine squared of x. Now let's turn these back into other trig functions, because I think that'll make things even more clear. So we're going to convert back. We have that 1 over cosine squared of x is the secant squared of x. And we have minus 1 is equal to sine squared of x over cosine squared of x. It's tangent squared of x. All right. Now, I'm going to do one thing. I'm going to add 1 to both sides. We have secant squared of x is equal to tangent squared of x plus 1. And that is one of the Pythagorean identities for trigonometry, and something that is a given. Hence, we can say, because tangent squared of x plus 1 is secant squared of x, that this side over here, this side, is secant squared of x, as is that side. So we have secant squared of x is equal to secant squared of x. Both sides are obviously equal because they look exactly the same. This is the reflexive property. So we have shown that the expression secant of x times the tangent of x minus the sine of x can also be written as sine of x times tangent squared of x. That's up from the problem that we were given right here. So right here and right here, that these two can be written to represent the same value, As we have shown, the two expressions are equivalent. Thank you for watching.